Hello, this is Sean McLaughlin from Education Analytics. This video is going to be about value-added analysis for use with the MAP assessment for New York's Annual Professional Performance Review, or APPR. This is work that Education Analytics has been performing for a number of years in districts in New York State. This is going to be a recording of what typically would be a live presentation or a webinar. I'm recording it so that everybody that missed one of those would be able to see this video instead. In this first one, what I'll be covering is an introduction to value-added analysis, and the three main topics that we'll be talking about today are what is value-added analysis designed to do, as well as value-added analysis 101, and in that section I'll be going over the oak tree analogy. And finally, we'll be connecting that oak tree analogy to the reality of how this works using the NWEA MAP assessment in the models that Education Analytics performs and delivers to districts for use in Annual Professional Performance Review, or APPR. So to start off, talking about what value-added analysis is designed to do. So it is designed to measure the effect of educators on student growth. There are a number of factors that can affect student growth, including starting knowledge. In particular, are there students that are higher or lower in the test scale to start? Do they tend to grow at higher or lower rates? Also, indeed, the effect of educators themselves on growth. Are there different strategies, different things that teachers and schools are doing? How can we figure out what that impact is on student growth? As well as student characteristics and family resources, those can also have an impact on student growth. For example, we might find that students who qualify for free or reduced price lunch status, they might grow at a higher or a lower rate when we look across whole groups of students. We would want to take that into account. Also, test characteristics can have an impact on how much growth is measured. All tests have some degree of measurement error. Other things about test scales that we would want to take into account, all those things might have an impact on student growth. So what is value-added analysis designed to do? It is using statistical techniques to isolate just the impact of educators on student growth. We want to factor out those non-educator factors, things like student knowledge, that's starting point before the educators start teaching those students. Student and family characteristics, we want to have those non-educator factors controlled out in the model. We want to take that into account. Also, any impact that test characteristics might have on student growth. Those are all things we want to take care of in the model. We want to adjust for those so that what we're left with in our statistical model of value added is we are left with the impact of educators themselves on student growth. We're trying to isolate that impact that teachers and schools have on student growth. And to unpack how we do that using a value-added analysis, we are going to go through the oak tree analogy. That's an introduction to growth metrics. So if you haven't seen any of these sort of things before, anything about growth metrics, anything about value-added analysis, what this analogy is designed to do is to unpack the building blocks of that methodology, and then we'll connect that back to how it's implemented specifically in New York State for use with APPR. So this oak tree analogy, what are we doing here? We are going to be explaining the growth of these two trees by evaluating gardener performance. We are going to have two gardeners here, gardener A on the left and gardener B on the right. We are going to be looking at, for the past year, these gardeners have been tending to their oak trees, and their goal is to maximize the height of these two trees. We're going to be evaluating a number of different ways in which the gardeners could be measured of their impact on these trees, and we're going to be explaining these different methodologies next. The first method would be measuring the height of the trees today. That's 1 year after the gardeners began tending these trees. And if we use that methodology, which gardener looks like the more effective gardener? If you look at our data, we have oak tree A on the left is 61 inches and oak tree B on the right is 72 inches. Using this method of higher tree equals more effective gardener, what do we find? Gardener B looks like the more effective gardener because that tree is higher. That is analogous to using an achievement model to measure the impact of these gardeners. And especially when I'm doing live presentations at this point in time, I like to ask, what is missing from our gardener evaluation? And almost always what I hear back is the following two things. One is, how high were the trees to begin with? These gardeners might not have started with acorns. We want to think about how that impact might have changed how much these gardeners impacted the growth of these trees, as well as Did the trees have different conditions during the year? Sometimes people say things like sunlight or rain or soil. We have the different environments that the trees may have been in during this past year. We're not thinking about that in our current methodology that we just explained earlier. We want to think about how can we get better at isolating what it is that the gardeners did on the growth of these trees. So I'm going to start off with thinking about what we just talked about how high were the trees to begin with. The achievement result does not tell the whole story. We want to find out the starting height for each of these trees in order to more fairly evaluate the gardener's performance during the past year. We can look back at our record and see that oak tree A on the left actually started off at 47 inches last year, 1 year ago today. And gardener B's tree on the right, oak tree B, started at 52 inches 1 year ago today. So the second method we would do is compare that starting height to the ending height using just subtraction of these two heights. And if we use that method, which gardener looks like a more effective gardener? If we do that little mental math there, we find out that gardener A's tree grew 14 inches during this past year, and gardener B's tree grew 20 inches. So if we were using this sort of method, it would still look like gardener B is the more effective gardener with that 20 inches of growth. That's analogous to using a simple growth model of subtracting either heights or test scores from 1 year to the next. That's a simple growth model. But thinking back about what was missing from our analogy, we thought about starting height, but also those environmental conditions that were outside of the gardener's ability to change. The gardeners didn't get to decide if it rained a lot that year. They did not get to decide what the temperature was during their oak tree's experience. So we had an apples to oranges comparison happening still. So for our oak tree example, what we've done is we've thought about three environmental factors that we would want to examine further: rainfall, soil richness, and temperature. We're going to try to level the playing field for these two gardeners by taking those three factors into account. If we look back at our record for our trees, we can see that oak tree A, during this past year of care, experienced high rainfall, low soil richness, and high temperature, while oak tree B experienced low rainfall, high soil richness, and low temperature. So there were very different conditions of these trees during this past year. We want to think about how much might that have affected the growth of these trees so we can isolate what it is that the gardeners are doing. What we're going to do to accomplish that is we're going to analyze real data from the region to predict growth for these trees. We're going to compare the actual height of those trees, oak tree A and oak tree B, to those predicted heights to determine if the gardener's effect was above or below average. So in order to predict these heights for these trees based on their characteristics, we need to find the impact of these different characteristics on the growth of trees. To accomplish that, we're going to use, this is just a stylization of how it would be used. In reality, there's a statistical model that takes place to find these impacts, but for the purpose of explaining what's going on, we're going to use this graph. We're going to look at the impact of rainfall, for example. So on the x-axis, left and right, we have the relative amount of rainfall that these trees experienced, each dot being an oak tree in the region. And on the y-axis, up and down, we see the amount of growth that we experienced from year 3 to year 4 for each of those trees. If we put a trend line through that, we can see that over on the right side, trees that had higher amounts of rainfall tended to be higher up in the graph, meaning they grew more. So this line, this tells us that higher amounts of rainfall were good for growth. Similarly, we find the same thing when we plot these same oak trees again, but this time looking at their soil richness. And we find the opposite impact actually in this data it's hypothetical data, of course, about temperature of oak trees. The higher the temperature was in this region, it appeared that there was lower amount of growth for these oak trees. So that's that downward sloping line here. So what we've done here is after this year, after the trees all grew, we looked at that data and find out what is the impact of these three different characteristics in this particular region during this particular time period. Now what we can do is find these trend lines and then make adjustments based on real data to make predictions that are customized for oak trees based on these three characteristics. So for example, in the previous slide, we saw that there was an upward sloping line for rainfall, meaning trees that had higher amounts of rainfall tended to grow more. That's what this +3 shows you in the rainfall high category. Trees that had made more rainfall tended to grow more. How much more? 3 extra inches when we analyze some data. So that's where this +3 comes from. Similarly, all these other factors, all these other adjustments here are reflective of those lines, those slopes that we found in the previous slide. Now what we can do is we can predict how high these trees would have grown based on the growth of similar trees in the region. We're going to start by making an initial prediction for each tree based on the starting height of those 2 trees. And then after we do that, we're going to refine those predictions further by accounting for rainfall, soil richness, and temperature so that we have an apples-to-apples comparison for the gardener's effect. So to start with that initial prediction, we would find for trees that had the same starting height for our 2 oak trees, oak tree A and oak tree B, how high did they tend to grow in our particular region? So we would find that trees that started at 47 inches, we might analyze some real data and find out that on average 47-inch tall trees tended to grow about 20 inches during a year. So that's the initial prediction of adding 20 inches for oak tree A. Oak tree A's predicted height is 67 inches. And I just want to mention that the prediction is not a prediction that's into the future, it's a statistical prediction. We need to find out how high did those 47-inch trees grow when they were at age 4 to then make a statistical prediction of how high oak tree A would have been under an average gardener's care. It's not that we're projecting the future for the oak tree, we're doing a retrospective analysis based on how similar trees grew. Similarly, for gardener B's tree, oak tree B, we might find that trees that started at 52 inches ended up growing 22 inches on average. So gardener B's prediction for their oak tree is 47 inches. Now we're going to start refining this prediction based on those environmental characteristics that we looked at earlier. For example, for rainfall, based on real data, we would adjust our prediction for these oak trees based on the different experience they had for rainfall during this past year. Oak tree A, if you remember, had high rainfall. Therefore, we're going to use the adjustment for trees that had high rainfall, and that's +3 inches. What does that mean? Basically, we're saying instead of oak tree A's prediction being 67 inches as it was before, we found that trees that had high rainfall tended to grow 3 extra inches on average. So we bump up oak tree's prediction by 3 inches to compensate for that external effect of rainfall that the gardener had no influence over. We're making that prediction a little bit higher due to the effect of rainfall on the growth of that tree. Similarly, oak tree B, we're going to bump down the prediction by 5 inches because we found that oak trees that experienced the similar amount of rainfall that oak tree B experienced, which was low rainfall, they tended to grow a little bit less, 5 inches less than other trees in the region. So we bumped down oak tree B's prediction by 5 inches to compensate for that external rainfall effect. Similarly, we are going to do the same thing for soil richness and temperature. Again, each time looking at the specific condition the tree experienced and then making an adjustment based on similar trees. So that by the time we do all that, our gardeners are now on a level playing field when it comes to the starting height of their trees, the rainfall of the trees, soil richness, and the temperature that those trees experienced, so that we have a customized prediction for each one of these oak trees. Now what we do is we are going to compare those predicted heights to the actual heights that those oak trees had after a year of gardener's care. So our method is we're going to figure out, did the trees exceed or not meet those predictions, and by how much? Using that methodology, what we find is that gardener A beat prediction by 2 inches and gardener B did not meet that prediction by 4 inches. In this case, we find that gardener A had above average value added and gardener B had below average value added. By accounting for last year's height and environmental conditions of the trees during this year, we have found the value each gardener added to the growth of the trees. One more note is that every tree counts in this group measure. What that means is that we're going to be looking at whole groups of trees to determine the gardener's effect. We need many data points to find out on average what was the gardener's impact on that whole group of trees, and in that way every tree counts. It's not just the certain trees that met a certain threshold or not. Every tree counts when we're thinking about the gardener's evaluation as a whole. Next, what I'm going to do is I'm going to link that analogy up to the reality of how value added is used in the annual Professional Performance Review, or APPR, in New York. In the analogy, our goal was to measure the performance of gardeners. In value added for APPR, our goal is to measure the performance of teachers, or in another analysis that we do, we also find the impact of schools. The growth data that was used for the oak tree analogy was the growth of height of trees in inches from age 3 to age 4. In value added for APPR, our growth data used is the growth of student test scores from fall to spring. In the oak tree analogy, our statistical prediction adjusted for the starting height of each tree, as well as rainfall, soil richness, and temperature, those environmental factors that the gardener had no control over. In value added for APPR, our statistical predictions for students adjust for the fall MAP score for each student, as well as the testing window, meaning the amount of time between the fall and spring tests for each student, the instructional minutes that occurred based on the SIRS data that we collect, how much time did the teacher have with those students in the same classroom, the different demographic characteristics of students, including gender, race, ethnicity, English language learner status, free reduced price lunch status, and special education status. All those different things come into play when we're thinking about our statistical prediction for each student. Then in the analogy, what do we do? So each tree got a customized prediction based on its characteristics. That included the growth for a different starting height of the tree, rainfall, soil richness, and temperature. That resulted in a customized prediction for each oak tree. In the education context, each student gets a customized prediction from education analytics based on his or her characteristics. So what we do is we look at the growth of students with that similar MAP score at the beginning of the year in fall, as well as adjustments for test window, gender, race, ethnicity, ELL status, free reduced price lunch status, special education status, in order to come up with a customized predicted score for that student at the end of the year. Where would they score on the spring MAP assessment? In order to find the gardener's effect in the analogy, what we do is we find out, did the tree exceed or not meet the statistical prediction, and by how much? For example, oak tree A had a prediction of 59 inches and actually achieved at the end of the year 61 inches. That means that oak tree A exceeded prediction by 2 inches. Similarly, in the education context, in order to find a teacher effect or a school effect, did the student exceed or not meet education analytics statistical prediction, and by how much? In this case, we had a predicted score for a student, and then the actual score ended up being higher at the end of the year. The student exceeded prediction by 5 points. In the analogy, a gardener is based on the average effect on a group of trees. And in education context for value-added and APPR, a teacher rating is based on the average effect on a classroom or more than one classroom of students. For more information about how value-added works and how it's applied in the New York project for APPR, please visit our website. We have some other materials up there, some other videos as well. And you can get more information there or contact us there if you have additional questions. Thank you.